Hey there, my name is James Brooks and I'm a software developer at Laravel. In this series, we're going to learn everything we need to know about Laravel Forge, the server provisioning and management tool that makes both of those tasks ridiculously easy and far less scary. In just a few clicks, we can provision a server with DigitalOcean, Linode, Vultr, Amazon, Hetzner, or we can bring our own Ubuntu server. Forge will automatically install and configure all the software we need for a secure and easy to use environment. And with our server provisioned, Forge takes the hassle out of deploying our applications, securing our websites with Let's Encrypt, configuring our queue workers, and everything we need to run our sites with. We'll start with the basics and work our way through to advanced Forge features that will make you a rock star. Okay, I can't promise you'll be a rock star, but you will be a Forge expert. Forge is loved by thousands of developers around the world, and it's not a surprise when it's managing over 100,000 servers, 500,000 applications, and taking the pain out of server management for developers everywhere. So let's get to it. To provision servers with Laravel Forge, we need two things. The first is an active Forge account, which I've gone ahead and created here already. And the second is an active subscription. We can manage our subscription by clicking on our name and going down to billing. You can see that I'm already subscribed to the business plan, but we can change our plan at any time by clicking the Change Subscription Plan button. And now we can see the different options available to us. Forge offers 3 different pricing points: Hobby, Growth, and Business, and we can toggle whether we want to pay monthly or yearly. Let's run through these quickly. The Hobby plan allows us to provision a single server, and we can run an unlimited number of sites on it. We can also deploy each of those sites an unlimited amount of times. The Growth plan allows us to provision an unlimited number of servers, and each of those servers again can have an unlimited number of sites, and those sites can be deployed an unlimited number of times. And then finally, the Business plan. Again, we can provision an unlimited number of servers, and again, those servers can have an unlimited number of sites and deployments, but we also have a few additional features. The first is database backups, which allows us to create automated backups of our database. And then we can choose to install a server monitoring agent onto our server. This will allow us to be notified when our server's resources hit a defined threshold. And then we can also share our servers with our teammates using a feature called Circles. And finally, the Business plan also offers a priority support level. For now, I'll keep my original plan. Okay, now that we have an active subscription, we can go ahead and click on the Create Server button. You'll notice that when Forge opens up this modal, that the first 5 options, DigitalOcean, Linode, AWS, Vultr, and Hetzner Cloud, are disabled. The reason for this is that we haven't yet configured our server providers. There's 2 ways we can do that. We can click on the Manage Providers button here, or we can select the provider of our choice. In this case, we're going to provision a server with Hetzner Cloud. And you'll notice when Forge redirects us to the new provider form that it's already selected the Hetzner Cloud option. Now, when you're creating a new provider, Forge is asking for 2 bits of information: the profile name and the API key. The profile name is just a way for you as the user of Forge to identify the token, because you can have more than one of the same provider. In this case, we're just going to call it personal. And I already have the API key in my clipboard, so I'll paste that in. Now when we click Add, Forge is going to validate those details and provide us with some information if that fails. But in this case, it's successful. So we have the ID of our provider, which we can use for API requests, the profile name, the provider type, and whether it's currently in use, which it isn't because we haven't provisioned any servers yet. Now that we've configured our server provider, let's head back to the Forge dashboard and click on Create Server once more. This time we'll see that Hetzner Cloud is enabled. When we click this, Forge is going to show us a form that we can fill in to select the server type, provide all the details of that server, and finally we can create it. We'll run through these quickly and revisit them in a future episode. With Forge, we can provision different types of server: app, web, worker, database, cache, MeiliSearch, load balancers. In this case, we're going to stick with app server that includes PHP, Nginx, database, Redis, and memcached. Pretty much everything you need for a self-contained application. Next, Forge will want us to provide a name, although it will randomly generate a name for us. Deep Sound is the perfect name for this server. Every server provider will have its own set of regions that we can select from. In this case, Falkenstein is perfect. The same is true for the server size. Each server provider will have its own offerings of resources. In this case, we're going to stick with the CX11, which contains 2 GB of RAM, 1 CPU, and 20 GB SSD. We can choose which version of PHP to install, anywhere from 5.6 to the latest version, 8.1. 8.1 is perfect. And finally, because we're provisioning an app server, we can choose a database to install on our server. Now, it's important to know that some server providers, such as AWS and DigitalOcean, have the ability to create a managed database. When you're using Forge, that is not what's going to be created. Instead, Forge will actually install the service that we select here on our server. So in this case, we're going to select MySQL 8. And because we're installing a database, Forge has already created a database called Forge, but we're free to change that. We could call it Demo or App or Forge. Okay, so provisioning a server typically takes 10 to 15 minutes depending on the provider, the region, the type of server and the amount of resources it has, and also the network that it's on. I'm going to go ahead and click on the Create Server button, and through the magic of movie editing, we're going to jump straight into our server. And just like that, our server has been created. Now Forge has taken us directly into the server panel here, where we can create a new site. But if we scroll down a little bit further, we can see active sites, which will show us a list of all of the sites installed on our server. You'll notice here that there is a default domain. Forge will install a default site for any app or web server, and the default site is what's used when your server is accessed over its IP address. Forge will install a temporary application that shows you how to install your project, set up your domain, and configure your DNS records. For now, we'll click into the default domain, where Forge will show us the Git repository, WordPress, and PHPMyAdmin options. WordPress and PHPMyAdmin just allow us to install these applications really quickly. But for now, we're going to focus on Git repository. You'll see here that we haven't yet configured our source control provider, and so Forge is only allowing us to install with a custom provider. We can fix this by going to our account settings and connecting to GitHub, GitLab, GitLab self-hosted, or Bitbucket. I'm going to use GitHub. Okay, once that's done, we'll go back to our site, default on Deep Sound, and go back to the Git repository setting. GitHub is now selected, and in this example, I'm just going to install Laravel. So the repository name is just the name that it matches on your source control provider. Unless you're using the custom provider, you don't need to provide the whole URL. Because we've supplied a repository and we're using the first-party integration, Forge is going to pull all of the available branches. Since our server has installed PHP 8.1, we'll install Laravel 9.x. And we want to make sure that Install Composer Dependencies is checked. Before we click the Install Repository button here, I want to mention a somewhat overlooked feature of Forge. When installing a repository from a Laravel application, Forge will helpfully copy over any .env.example files that exist in the project's root, and it will copy that content into the .env file and automatically update some of those environment variables such as db host, db user, etc. And so that we can get on and deploy our application really quickly. So let's go ahead and install the repository. Typically this will take a minute or two, but of course it depends on the size of the server, the repository, and the number of dependencies that your application is also installing. And with that, our first site has been deployed. Let's go back to our site's IP address and give that a refresh. And you can see here that Forge has now replaced that temporary site with our Laravel application. Nice, but how did this actually deploy? Well, Forge has created what it calls a deploy script, and it tells your server exactly which commands to run when deploying. Deploy scripts are an important part of Forge and can look pretty overwhelming, but don't worry, we'll take a deep dive into exactly how all this works later. For now, we can see it's performing a few key actions. We're pulling our changes, we're installing dependencies, we're reloading PHP, and then we are running our migrations. Since we don't need any migrations at this point, we can comment this out and click Update. Finally, let's take a quick look at the Environment tab here. Forge shows us the contents of the .env file directly from our application, which we can modify and save right here without needing to SSH in or connect via SFTP and make manual adjustments. We can change the application name, Laracasts, and go down to here and click Save. Once saved, we can go back to our Application tab and click Deploy Now. Nice, everything deployed successfully. Wow, that was a whirlwind of a tour of just some of Forge's features. Let's take a second to recap what we've done here. We started by connecting to our server provider, Hetzner. We provisioned an app server which installs Nginx, PHP. We chose to install MySQL and Redis. Then we changed our default site to deploy our own Laravel code. Don't worry if this felt overwhelming. We're going to go over all of this in much more detail over the next several episodes. I'll see you in the next one. In the last video, we subscribed to Forge, configured our server and source control providers of choice, then provisioned a server and deployed the Laravel repository to it. Now with our app or web server provisioned, we're able to create and manage our own sites. Creating a site is ridiculously easy in Forge, but first we need to go back down to the active sites list here and just go over a couple of things. As we mentioned in the last video, Forge creates a default site. That is, that the root domain is just simply called default. This site responds to any request made to the server's IP address. Of course, you're free to delete this site from your server, and requests will then start to return a 404 status code. You may always recreate the default site by creating a new site with a root domain of default. The second site is actually hidden from the active sites list. And this is a special site that tells your server to drop any requests from domains that are not yet configured on your server. This is to prevent malicious domains from pretending to be owned by you. And any requests made to sites that do not exist on your server will return a 444 status code, which simply tells Nginx to immediately drop the connection without sending any response to the client. Okay, let's take a look at the new site form. First, we're asked for the root domain, which is just the primary domain name of our site. Forge will also use the root domain as the name of the directory in which our code will get cloned into. In this case, we're going to create a site called zonda.quest, because we're all on the quest for that Zonda goodness. Next, we can provide aliases of our site. This will typically be used if you're running a multi-tenant application with just a couple of subdomains. Keep in mind that site redirects and security rules will apply to all domains listed in both the root domain and the aliases list. Now, although Forge is a Laravel product, it can deploy more than just Laravel applications. When we select the project type, you'll see General PHP and Laravel, Laravel Octane, Static HTML, and different versions of Symfony. For now, our site is going to be running Laravel, so we'll leave it like this. The web directory is where our index.php or index.html files live. Now typically this is just going to be left as the default public, but if we're using Forge in conjunction with another product like Envoy, we might want to update this to /current/public. In this case, we're going to leave it as public. Now, if our server is running multiple versions of PHP, we can select which version we want to use. Since this server is only running PHP 8.1, that's my only option. And now, at the bottom of the form, there are 3 checkboxes. If you're running a multi-tenant site where customers can subscribe and create their own subdomains, you wouldn't want to update your site every time a new customer joins. Instead, you can enable this option and Forge will automatically configure your site to respond to any subdomain. Website isolation is an advanced feature of Forge that creates your site within its own PHP FPM pool. This means that a new system user is created and runs the entire PHP FPM process instead of the default Forge user. This is particularly useful if you're going to install WordPress and additional third-party plugins that might contain malicious code. This will stop it from being able to modify files outside of its own home directory. Finally, because we've created an app server which contains a database, we can also create a new database alongside our site. For this, we're going to call it Zonda. Now let's go ahead and add our site. Now once Forge is finished installing it, we'll need to go ahead and update our domain's DNS records to point our domain to our server's IP address. And you should make sure that you create an A record for the domain name. And be warned that DNS changes can take up to about 48 hours to propagate, so you may need to wait for these changes to become live. Now that our site has been created, Forge will allow us to install a repository. If our server is an app server like this one, then Forge will also provide us with the ability to install WordPress and PHPMyAdmin instead of our own code. And so long as we have created a new database and database user, we'll be able to go ahead and use those options. Now, when installing a Git repository, we can select our provider of choice. In this case, I've only linked GitHub to my Forge account. We can, of course, connect multiple Git providers through the account settings page, which we can access by clicking this link. Alternatively, we may use a custom Git provider, which is perfect if our code is hosted elsewhere. Now, since we're using GitHub, we'll use that. Once we've entered the repository name, Forge is automatically going to fetch the available list of branches and suggest them in the branch input field. For this repository, we're just going to go with main. And since we're deploying a Laravel application, I'm going to make sure that I'm installing Composer dependencies. Finally, we have the option to generate a deploy key. Now, this is an advanced feature which is useful if we're going to give Forge access to perhaps a specific repository that might not be owned by our connected Git account. We can then go ahead and install our repository. Now, whilst Forge does this, I want to point out that when installing a repository, Forge is actually doing what's called a shallow clone with a single branch. This means that your site will only have the branch clone that is being installed and only the most recent 50 commits. This means that you can't simply SSH into the server and switch branches or jump through the Git history. You'll need to run some additional commands to do this. Forge does this to speed up the installation process, as larger repositories can take quite a while to install. Now that the site has been installed, Forge has redirected us to the Zonder.quest panel. If we click into the environment panel, you'll notice that Forge has already created and configured the environment file for us. We mentioned in the last episode that Forge does this by copying the .env.example file and automatically updating some of the variables so that our application can be deployed and made live quicker. You'll see as well that we've already generated the key used by the application. Of course, we can make changes to this file and save them at any time. We've seen already that Laravel Forge does much more than just provisioning a server. So far, we've provisioned a server, we've created the ZonderQuest website, and installed our own code into it. But what happens when our code changes? Well, we need to deploy our code again. A deployment is the process of taking our latest code changes and getting it cloned onto our server and made live for our customers and users to see. A single deployment can do many things, but by default, we will change into our site's directory, pull down the changes in Git, install Composer dependencies if we've opted for that setting, reload the PHP FPM process, and if the artisan file exists in our site's directory, we'll run our migrations. Since we don't need to run the migrations, let's comment this out for now. And this is all done within what Forge calls the deploy script, which itself is just some bash code that tells Forge exactly what to do with your site. Now, if we look at this editor, you may already have noticed that Forge is using some special variables, $forge_. These are special Forge variables that are dynamically injected during the deployment process. There are dozens of variables that supercharge our deployment scripts. You can learn more about these on the Forge documentation. Speaking of variables, the deploy script form also has a checkbox here, make.env variables available to the deploy script. If we check this, Forge is going to take any of our .env variables, say app name, app env, app key, and make them available to our deploy script. Now, it's not a particularly useful demonstration of this, but let's say we wanted to output that our site name is deploying. Let's go ahead and update our deploy script and click deploy now. Once the deployment is completed, we can view the latest deployment log and we will see ZonderQuest is deploying. That's cool. But be warned, when using this setting, variables such as DB password, app key will all be made available in the same way. The default deployment script that Forge creates for us is quite simple, but we're of course free to modify it to do what we need. For the application we're deploying, we'll cache both our config and our routes. Now Forge will store the last 10 deployments for us. We can see these by going over to the deployments panel. Not only can we see when and who initiated the deployment, we can also see the branch that was deployed, the commit, how long it took, and the status. We can see that we have one failed deployment here, and we can see the output of why it failed by clicking the View Output button. If we scroll down, we'll see that there was no database called zonda.quest. Nice. When using Forge, there are 3 ways we can deploy our site. The first is with the Deploy Now button. The second is by enabling Quick Deploy. And the third way is to trigger a deployment using the API. We can see how our site was deployed by the icon that shows to the left. Speaking of Quick Deploy, let's see how we can enable this. Let's go to the App panel and enable Quick Deploy. If you're using a custom Git provider for your repositories, you won't see this button, and this is because Forge has no API to communicate with. When we enable this, Forge is going to add a webhook to our repository that listens to all push events, and when any pushes are made, Forge will be notified and immediately trigger a new deployment. Now let's imagine we have a one-off command that we need to run within our site. Perhaps we want to seed a database or trigger a different artisan command. Your first thought might be to modify the deployment script, save it, and redeploy. However, Forge has a much easier way of doing this through the commands panel. Forge makes it really easy to run these one-off commands and even goes as far as suggesting common commands for us to run. Let's just migrate our database. Of course, you can run different commands here, such as the ls-la command, or maybe you're running a different project. You're free to run any command here. Once our command is finished, we can then view the output of it by clicking the 3 dots and View Output. Here we can see that our migration tables were successfully created. Nice. Be aware that Forge will only track the status of a command that runs for 2 minutes or less. This means that if a command takes any longer than 2 minutes, Forge will report it as failed, even though that strictly isn't the case. And we'll finish off this episode by taking a quick look at how we can fix common deployment issues. Forge even has a self-help menu that we can use to reset both the deployment state and also reset the Git state, which can be used if our directory contains any unstashed changes. We've now set up our site, deployed our code, and ran a couple of commands. Everything has been running great for a while now, but our marketing team have come to us to suggest that we need to change the About Us page of our site to Company. Now, we don't want to maintain 2 routes in our application that render the same view, and we also don't want to lose SEO rankings for our About page. And remember, duplicated content is not SEO friendly, so even if we could maintain 2 routes, we most certainly don't want to. Now, thankfully, we can create redirect rules for our site in Forge. So if we go to the site page and go down to the redirects panel here, we can see that Forge makes it super easy to manage these for us. We just need to provide 3 bits of information. Firstly, the from, which in this case would be about us. The to is where we want to redirect to, which is company. And then finally, the redirect type. Now, Forge allows us to do a temporary and permanent redirect. Temporary is a HTTP status code of 302, and permanent is 301. Now, these don't sound particularly different if you've never done anything with redirects, but a temporary redirect will mean that anytime a customer visits your website on this from page, it will always hit your server to see where it needs to go. Now, this means you can change these redirects in the future, no problem. Now, a permanent redirect will mean that the browser caches where this redirect takes us to, and the next time we hit this page, the browser is going to skip hitting your server and go straight to this page instead. Okay, let's add this redirect rule. We can see it's being added here. Now, if we visit our site and we go to our About Us page, we can see it's taken us straight to the company page. Okay, so we've created a pretty simple rule here. We've gone from one static page to another static page, but we can also use this panel to create more advanced redirect rules. Let's switch back to our site. We can see here that we've now got product-info / a product ID. And we can see when we view this page showing old product URL number 2. And if we change these, we can see that we've also got 3 and it's dynamic here. In this case, we want to redirect to just simply product number 3. We can do that by using a regular expression rule. To do that, we'll put in a caret product-info / and then we're going to create a capture group here where we only capture digits between 0 and 9, and we'll capture as many of them as we can. And we'll stop that rule when it hits anything other than what's in this capture group. And we're going to redirect to simply product and then $1. The $1 here will evaluate to whatever this capture group is here. We'll create a temporary redirect rule for the sake of testing this. Add that. We can see it's being installed. Okay, if we switch back to our site, we should now go from product-info to simply product. There we go. We've redirected. And we can test this by going to another URL, product URL 99. Yep, we've completely redirected here. Now in Nginx, there are multiple ways of creating redirect rules, and actually you can go even more advanced than what we've created here. To do that though, we will need to SSH into our server and manually create the rule. So Forge stores these redirect rules in /etc/nginx, forge-conf, and then the name of our site, and then server. If we redirect, we can see here that we've got this redirect rules configuration file. If we cat the contents of this, we can see our rules have been created here. Now, you don't want to write directly to this file because Forge is going to rebuild this anytime one of the redirect rules is updated or created. Instead, you would maybe want to create your own custom redirect rules file and put in the contents of this here. Of course, you'll notice that the directory is not writable, and that's because we're currently logged in as the Forge user. So we would actually need to do sudo custom redirect rules.conf. Of course, if you're looking to get into even more advanced rules here, it would be worth checking out the Nginx rewrite rule documentation, because this completely explains everything you need to know, including how you can use things like the user agent and cookies to redirect further. Right now, our site is available to anyone who knows the domain zonder.quest. And typically this is what most sites will do. But sometimes we do need to protect access to our sites. Perhaps we're working on an internal site, or we want to authenticate a user before they can see something. Now all Forge sites will have a security panel that allows us to create a new security rule. And this will protect our sites with a username and password. And like everything else, Forge makes it really easy to create the security rules for our site. Let's run through this. Some browsers will show us the name in the authentication dialog when we try to access our site as an unauthenticated user. Typically, the default is fine. The path is the endpoint that we want to protect, and we can leave that blank to password protect all of the routes on our site. Of course, any valid Nginx location path is acceptable, since this is just configuring Nginx behind the scenes. For now, we'll leave this blank. And finally, we can enter a username and password that we can use to authenticate ourselves. We can create as many users as we need by clicking the plus button, or we can remove them by clicking the X. Let's create James. And I can't think of a very secure password, so we'll just generate one for now and copy that. And we'll also create Taylor, because the boss always needs access. And we'll generate this password again and click create. So we can see here that the security rule is being created, restricted access everywhere, and we have James and Taylor. If we go back to our site and refresh, you can see we're now asked for our details. And we'll use James and the password. And when I click sign in, we're now shown all of the information. Now for most people, the security rules generated by Forge will cover the majority of what you need. However, sometimes we do need to be a bit more bespoke. And like everything else generated by Forge, you are free to modify or create new additional Nginx configuration files. Let's SSH into our server and take a look at where these files are stored. Security rules are stored in the etc Nginx directory, and then within that, forge-conf, and then the name of our site, and then finally, server. If we take a look at what's in this directory, we can see that we have our redirect rules from a previous video, and then two additional files here, .ht password, and then the ID of our security rule, and then the protected site configuration file. These two files tell Nginx how to protect our site and who should be able to authenticate themselves. If we take a look firstly at the htpassword file, we can cut the contents of that. We'll see that we have two users, James and Taylor, and their hashed passwords. We can also take a look at the protected site file, and we can see here that we are using auth basic. Auth basic, or basic authentication, is what tells the browser to ask for a username and password. Nginx will then verify those details against a user file, which is our .htpassword file with these username and passwords. Of course, we can always modify any of the protected site configuration files to make any customizations that we need to. You'll notice firstly here, because it stands out like a sore thumb, Nano is complaining that the file is currently unwritable. That's because I'm currently only the Forge user. I would need to escalate to the root user using the sudo command, and then I can make the file changes that I need. Once the changes are made, I will also need to reload the Nginx service. That will tell Nginx to reload all of the configuration files and pick up the modifications that we've made. Now, when customizing any of the configuration files, I would always recommend referring back to the Nginx documentation. The documentation goes into far greater detail as to how the whole thing works. It also includes some really cool examples. For instance, how we can combine basic authentication with access restriction by IP address. You can see here that we're scoping down the authentication rule to the API endpoint and then subsequently denying or allowing certain IP addresses or ranges. Finally, you may have noticed this Nginx Plus. This is a premium version of Nginx that provides some additional features. However, this documentation also says Nginx Plus and the open source version, which is the one installed by Laravel Forge. Just be careful when finding documentation because some of its documented features might not apply to the open source version. It's now so easy to secure a website with HTTPS that we'll have a hard time finding any reputable website that's just not doing it. In fact, some TLDs such as .dev and .app require the use of HTTPS on any domain using them. Now, if you're not familiar, HTTPS is a secured version of HTTP that uses an SSL certificate to encrypt and exchange connections between the user and the server. Kind of like how we use a private and public key to SSH into our Forge servers or to push to GitHub. We can manage our site's SSL certificates by going to the SSL panel in our site's dashboard. Forge offers two methods of securing our website. The first is through the use of a free service called Let's Encrypt, which generates an SSL certificate on our server and automatically renews it for us. The second way is to import our own certificate, which we can do if we've purchased a certificate through an external provider such as Cloudflare or our domain provider. We'll start by configuring and installing a Let's Encrypt certificate. Now keep in mind, there are two things you need to know when using Let's Encrypt. The first is that Forge will configure your site to automatically renew your certificate within 21 days of its expiry date. The second is that if you cancel your Forge subscription, your site will remain secure until it's due to renew, at which point Forge will not be able to renew your certificate and your site will become insecure. Installing a Let's Encrypt certificate is ridiculously easy. In fact, Forge has done most of the work here for us. It's already filled in our domains, zonda.quest as our primary domain, and our www.redirect, and then it's selected the public key algorithm. Now, in most cases, you're going to want to use ECDSA, but sometimes you might need to use RSA, which is a legacy version. Finally, we can opt to prefer the ISRG root x1 chain, which is a bit of a mouthful. It's recommended that you keep that option disabled, and whilst it will work, you will find that older Android devices will not be able to reach your websites. Now we've seen how we can install a Let's Encrypt certificate, but we need to now look at how we can do manual certificates. There's two options here. We can create a sign-in request, which is also known as a CSR, and this will generate a private key that we can then use to purchase our own certificate with. If we've already done that, or we've generated a certificate already, we can install existing. Now here we need a private key and a certificate. So I'm going to switch to Cloudflare, which is my domain provider in this case. And I'm going to go to the Origin Server tab under SSL and create a certificate. Now the first thing that we're asked for is whether we want Cloudflare to generate a private key and CSR or to use our own. So if we just jump back here, We could create our own sign-in request and provide the key to Cloudflare, but in this case, I'm just going to let Cloudflare generate those. The next thing is the host names that we wish to have this certificate valid for. I'm going to leave this with all subdomains of zondo.quest and the root domain of zondo.quest. I'm also going to allow the certificate to be valid for 15 years, but we could choose anything that we want here. So we will create the certificate. And now Cloudflare has generated the certificate and the private key for us. You'll see that there are a couple of different key formats, but we just want to stick with PEM here. So the first thing we need is our private key, and we will paste that into Forge. And then we also want our origin certificate, which we'll then paste into Forge. When we install the certificate, Forge isn't going to initially activate it, so our site won't be secured. What it's doing here is just installing the certificate onto our server, and then we can go ahead and activate it. Okay, and with our certificate activated, SSL is now enabled on our site. Now, when using Cloudflare to manage our SSL certificates, sometimes we may need to go and enable either full or full strict as the encryption mode. This is to verify that our origin certificate that we just added is actually correct and trusted. When you provision an app server with Forge, you can also choose to install a database server alongside it. You can select MySQL, Postgres, or MariaDB to be installed as a service on your server. Alternatively, you can provision a database server which exclusively runs one of the database services. Your other servers can then connect to it through the use of a private network. Now, databases can be managed through the database panel on our server's dashboard. This panel has a lot of features, so we're going to run through each one of these individually. The first thing that we'll see is that Forge has generated the database connection URL. This URL is a standard that can be entered into applications such as Table+. Let's go ahead and copy this into our pasteboard and switch to the Table+ application. The next thing we need to do is create a new connection and click Import from URL. Now, Table+ has identified that we already have this URL in our pasteboard, and so we can just click Import. We can see that Table+ has already pre-filled the connection details with everything that was in that URL. The only thing that we need to supply here is the database password. If you don't have the password, it will be included in the email that was sent to you when the server was finished provisioning. We can test this connection by clicking Test. And when we're happy that everything is connected, we can then click Connect. Now, we're already connected to the Forge database here, but we can switch to our Zondo database and verify that our migrations have created all the tables. Yes, they have. And that's how we can use the database connection URL. The next thing we can do is create additional databases. If we think back to when we first provisioned our server, Forge created a default Forge database and database user for us. Now, by default, the Forge user will also have access to all newly created databases. So when we're creating a new database, we can also create a user that will be granted explicit access to this database only. Let's create a blog database, and we'll also create an additional user called blog and a randomly generated password. Let's create that. And we can see that Forge is now installing the blog database for us. Once that's created, we can switch to Table+, refresh our connection, and switch database to see the blog database. Now, whilst we're looking at this databases panel, you'll also notice the Sync Databases button. This can be used to pull in databases that were created outside of Forge. So, for example, if we switch back to Table+ and create a new database called Demo, we now have this demo database. Let's open that up. Okay, cool. It's an empty database. Now let's refresh Forge, and you'll see here that we're not being shown the demo database. That's because Forge only knows about these databases because they were created through the Forge dashboard. So if we want to get our demo database back into Forge, we can simply click Sync Databases, and then yes, we do want to proceed with that. Now Forge is going to go and look for all the databases on our server, make sure that they don't already exist in Forge, and pull them in. And we can see that Forge has now synced in our demo database. Okay, the next thing is that we can add database users. So although we could create a database user while we were creating a new database, this particular way of creating database users allows us to specify which databases this user can access. So let's create a Laracasts user, generate a new password, and we're going to give it access to the blog and demo databases. Okay, and we can see here that the Laracast user is being installed. Brilliant, that's done. Okay, so the other thing we can do here now is edit these users and either change the password or change the access levels. We could also select all databases or no databases. Finally, we can delete users as well. Let's delete this blog user because we don't need it. And just like that, the database user has gone. Now we can also change the Forge database user password. Changing this password outside of the Forge dashboard will mean that Forge is no longer able to manage your database for you. You'll need to contact the Laravel Forge support team to get this updated for you. Now the last thing we can do here is manage our Redis password. This won't really do too much, but it will mean that if we change this, we might need to update our environment file as well. These days, it's common for modern applications to schedule jobs to run every minute, every hour, or even something super specific such as every half past the hour, but only on Mondays. You can easily schedule your own jobs through the Service Scheduler panel. Behind the scenes, Forge is simply managing the cron tab configuration file for us. As we scroll through the Scheduler panel, we can see here that Forge has already added 2 scheduled jobs that we did not add ourselves. Now when Forge provisions a server, it will configure these 2 jobs for us. The first command that Forge will configure is to tell Composer to update itself, and it does this on a custom frequency, and in my case this server is configured to run at 20 to 6 on an evening. Each server will randomly generate its own frequency, and it does this to prevent all servers from updating Composer at once and avoiding any accidental DDoSing of the Composer website. Forge also configures a command to automatically remove and clean any leftover dependencies that may be lying around since the server has updated itself or we've installed additional software such as PHP. We can click onto the menu here and we'll see 3 options. We can show the output, pause the job, or fully delete the job from our server. If we show the output, we will see in this modal the command that we're running and also the output. Here we can see that we're already running the latest version of Composer. Nice. Now let's go ahead and create our own scheduled job. When creating a new scheduled job, we need to provide Forge with 3 bits of information. The first is the command, which is what we want to run. The second is the user who should run that command. And then finally, the frequency, or how often that command should run. So since our application is built with Laravel, we're going to schedule the schedule run command, which is what this placeholder is suggesting here. When we click into the command box, Forge is going to suggest 2 versions of PHP that we can use. Now PHP without the version number is the default CLI version configured on the server. We can verify which version of PHP is the default by going to the PHP tab, and then scrolling down to PHP versions, and we can see our server only has PHP 8.1, which is also the CLI default. Now a good practice is to always be explicit about which version of PHP is going to run our command. This means that if the server's default CLI version ever changes, our command will always run without being affected. In this case, I'm going to use PHP 8.1, and then I'm going to specify the path of my command, which is home forge zonda.quest, and then artisan, and then finally I'm going to schedule the schedule run command. I'm going to leave this as the Forge user because that's the user who runs our site. And then finally the frequency. With the Laravel scheduler, I'm going to leave this as every minute because it's within that we can configure how often our commands within our application should run. However, if I'm scheduling a different command that isn't using Laravel scheduler, I might need to get into a custom frequency. So here, every minute is bang on the minute, every hour is bang on the hour, every night is at midnight, every week is every Sunday at midnight, and every month is the first day of the month at midnight. Now the two that are a little bit more confusing are the onReboot and the custom options. When we use onReboot, Forge is going to configure a command that will run when our server restarts. So once it's finished initializing and everything is set up and the cron service is running, this command will be executed. And then finally, we have the custom command. This allows us to specify a very granularly controlled frequency that our command should run at. It does this using something called a cron expression, and this is a way of representing how often a command should run. And here we can see that Forge is showing us when this command is due to run. So because this runs every minute, it's going to run at 12:04. We can change this to run only every hour, which is the same as the hourly command, or we could say every 1 to 15. So between minutes 1 and 15, this command's going to run. We could say that this command can only run between the hours of 7 p.m. and 11 p.m. So we could do 19 and 23. And then we can see that this command will now run at 7 o'clock. Okay. For now, we're going to go back to every minute though, and we will then create our scheduled job. We can scroll down to see that our job is now being installed and is active. So if we immediately go and show the output of our command, it's unlikely that this command has got any output. There we go. This job hasn't run yet. This is because the next minute has not yet passed. However, if we give this a bit more time to run and we wait a couple of minutes, then we'll start to see that the output is showing. There we go. This command is now running, and we can see the Laravel output, running scheduled command, artisan inspire. Nice. So how is Forge managing all of this? Well, if we SSH into our server, and then we clear this content, we can cat out the etc cron tab file. Now when Forge creates these scheduled jobs for us, it's actually writing to this etc cron tab file with all of the different cron expressions in. If we view this, so the first thing we notice is that there is a provisioning cleanup script here. And Forge does this because anytime you run a command on your server through the Forge dashboard, it's actually uploading a bash script first, and then it's writing the output of that to a log file, and Forge will clean these up every 30 days or so. And then beneath this, we can see the 3 scheduled jobs that we have in our dashboard. Now let's have a look at how Forge actually writes these. So first the expression, the user, and then the command that we're running. And we'll notice here, which we didn't put into our scheduled job, it's writing the output or piping the output of this content into this scheduled log file. And we can take a look at this log file by copying that path and doing a cat. And we can see that command. So when we open the modal to show the output, this is the content that Forge is actually showing us here. Now for the most part, you'll find that scheduled jobs run without any issues, but occasionally you might find that all of your jobs will stop working for some inexplicable reason. Now usually this happens because just one command is not configured correctly. That's all it takes, one command, and the whole cron service will come to a halt. Now often the reason for this is that the user you're trying to run a command as, so Forge or root, that user no longer exists. And often this can happen when you have an isolated site and then you remove it, but the scheduled job still exists. So what you need to do is just make sure that those scheduled jobs are removed for any users that no longer exist on your system. Once that's done, the cron will continue to work as normal. Laravel ships with the ability to push time-consuming tasks into a queue. Each queue job gets executed asynchronously by a worker away from our main application. And a queue worker is a process that looks through the stack of jobs in the queue and executes them one by one. We can configure our application to run one or more queue workers, allowing us to control the number of jobs our application can process at any one time. In Laravel, queues are configured within our application's code through the config queue configuration file. Here we're able to configure different queue connections and the queues themselves. By default, Laravel creates a queue configuration file with several connections already configured for us. Here we can see sync, which will run our queues synchronously against our code, database, beanstalk, SQS, and Redis. When I first started working with queue jobs myself, I was confused by the difference between connections and queues, but actually it's pretty simple. Think of the connection, which is Redis in this case, similar to how we can configure MySQL, Postgres, or SQLite for our database. For our queue connection, we may want to use Redis, our database, or Amazon SQS. There are a bunch of options available to us. And the queue configuration is the pile or stack that we want to add jobs to within this connection. If we put it all together, we may want to push our jobs to the Redis connection, and then we could have two queues, one for notifications and one for queue uploads. This way we can configure our queue workers to process the uploads queue faster by adding more workers, but letting our notifications work slower as they may not be as critical to our application. Now, some queue drivers will require additional packages to be installed. Redis is one of them. Let's see what we can do to install that. To use the Redis connection, we'll need to require Predis in our application. This will add the Predis dependency to our Composer JSON and lock files, and we'll now be able to use Redis as our queue connection. Now let's switch back to the Forge dashboard and see how we can configure our queue workers. On our site, we will go down to the queue panel and we can create a new worker. So here, the connection is the connection that we want to use, which could be Redis, and the queue could be notifications. Forge already provides us with some same defaults for the rest of the queue options. Queue jobs may run for 60 seconds. We can configure how many seconds to wait before processing new jobs, the number of times a job should be tried, and if we scroll down further, which version of PHP the worker should run with. Of course, there are many more options here, and if you're unsure what these settings relate to, you should read the Laravel documentation. The docs go into far more detail about how these settings can be configured. Aside from the connection and queue fields, we're going to leave everything else as the Forge defaults to create this worker. Let's create that now. So while this installs, let's explain how this works. Forge is going to create a supervisor configuration file, much like it does for the daemons. But instead of us having to create a daemon and supply all of these potential parameters, Forge is actually going to just do that for us. With a queue worker created, our application can now start to process any jobs that we push to the queue. Of course, we can manage the queue workers too, we can restart it, and we can also view the output to ensure that things are running smoothly. In this case, we have no jobs on the queue, so there is no content available. We're also able to see the worker status of all of our supervisor jobs here. We can see that we have an existing daemon and also a worker. If we're building an application that relies on a service to run indefinitely in the background, then we would need to create a daemon. A daemon, or sometimes pronounced as daemon, is a background service that runs a particular application for us and will automatically restart it if it stops. We can create a daemon within Forge through the Server's Daemons panel. And in the background, Forge is going to configure something called Supervisor to run the command for us. Now in our Zonderquest application that we've been building and deploying, we've also installed Laravel Horizon. Horizon, if you're not sure, is a package from Laravel that manages our Redis queues and also provides us with a dashboard to see how those queues are performing. Horizon also provides us with a command that spins up a long-running process, and that's what's responsible for running the different queued jobs. Now, if we were to put the artisan Horizon command into our deploy script, then our deployment would just never end because that Horizon command is running the long-running process. Instead, we would create it as a daemon. To create a new daemon, we need to go to the Server's Daemons panel. Now, if we just scroll down and get this whole form on the screen, perfect. So we need to specify a couple of bits of information. And although there's a few form fields here, Forge has already provided us with some common defaults. We do, however, need to specify the command because we need to tell Supervisor exactly what it is that it's running. In this case, we're going to do PHP 8.1 artisan Horizon. This is the command that we need to run to start the Laravel Horizon. Next, we need to tell it where to run this command. Now, because this artisan Horizon command is within our application, we need to give it the directory of our site, home, forge, zonder.quest. But let's say we're configuring something like Sockety. Sockety is just installed globally on the server, so we don't need to specify a directory. Now we need to say which user is running this command. For Horizon, it needs to match the same user that's running our site, so we will stick with Forge. We can also specify the number of processes that supervisor should spin up to run this command. However, Horizon is going to be doing this for us, so we can just leave this as 1. Now we can also specify the number of seconds that the program must be running for before supervisor is going to report to us that it's been successful. Horizon starts very quickly here, so we can leave this as 1. Next, we can say that when the command is told to stop, we'll allow it to stop for 10 seconds before supervisor will just force it. So for example, our Horizon command might need to close up some things, wait for some jobs to finish running, then close the connection to Redis, etc. That could take a few seconds. So we'll give it 10 seconds to stop for before Horizon is just going to terminate it. And then finally, we can specify which stop signal to send when we tell supervisor, stop running Horizon. These are quite an advanced thing here, and so you should refer to any documentation of the command that you're using. Horizon is fine and we'll listen to a sigterm stop signal, so we'll leave it with that. And then we can create our daemon. With our daemon now installed, Forge provides us with a set of utilities for managing it. The first thing we can do is see the daemon's log file. Now Forge has configured supervisor to log any of its standard output into a certain log file, and then Forge is now displaying that content to us. Here we can see that the command is PHP 8.1 artisan horizon, and the output from this command is horizon started successfully. Now Forge will only ever show us the last 500 lines of log file. If we needed to, we could choose to clear the log file completely. Next, we can see the status of the daemon. Now this is what's going to show us the true representation of the daemon on the server. The status listed here only reflects any of the commands ran through the Forge dashboard. That means if we were to SSH into our server and manually stop the supervisor process, Forge wouldn't reflect that in the UI. Here we can see the command again and the status of this daemon. It's running, and here's the process ID, and it's been up for 2 minutes and 10 seconds. If we had configured the daemon to run multiple processes, then we would see each of those processes listed underneath. We're also able to restart, start, and stop the daemon. If we stop it, then the whole command is going to be stopped, and it will follow the same signal that we configured here, and it will allow for the number of stop seconds that we configured before the process is forcefully terminated. Next, we can edit the supervisor configuration file. This is the actual configuration for supervisor that Forge has already generated for us. And we can see here that it's also added some additional settings that we didn't need to set ourselves. Any manual adjustments we make to this file won't be reflected in Forge. For example, if we were to change this command and save it, then Forge is not going to reflect this command in the UI. And then finally, if we no longer need the daemon, we can delete it. This will completely remove the configuration file from our server and also remove the daemon from the Forge dashboard. When we first provision an app, web, or worker server, we are able to select one version of PHP to install on the server. However, sometimes our server may need to run multiple sites, each with their own PHP requirements. Now, we could always provision a new server, one for each version of PHP that we require, but Forge actually provides a way for us to install and manage multiple versions of PHP. Let's head over to the PHP panel on our server's dashboard. And we'll scroll down. The first thing we're shown is two forms, one for the max file upload size and another for the max execution time. If any site on our server needs a larger max upload size or a longer maximum execution time, we can set these settings here. And if our server is running multiple versions of PHP, these settings will be applied to all versions on our server. To set the maximum file upload size, we can simply enter 10. And this would set the setting to 10 megabytes. And then for the max execution time, we need to set the setting in seconds. Let's say 60 seconds is plenty. And there we go. Next, we can manage opcache. Opcache is used to store the compiled PHP code in memory, and when it's enabled, we'll often see a greatly improved performance of our application. Now, if we enable opcache, we must make sure that the deploy script is reloading the PHP FPM process. By default, Forge does include that into deploy scripts, but we should check for older sites. And now the main feature of the PHP panel allows us to manage the versions of PHP installed on the server. We can see that this server only has one version of PHP installed, PHP 8.1. And because of this, it's both the CLI and site's default. This means that if we were to run PHP on our server, we'd find it's running 8.1, and if we were to create any new sites through Forge, it will be configured by default with PHP 8.1 too. Every version of PHP installed on the server can be patched, which means updated to the latest minor patch version. When patching a server, there may be downtime as the PHP FPM processes would need to be restarted. And if we click on the button next to the version of PHP here, we're also able to modify a few configuration files: the PHP FPM, CLI, and the pool configurations. Each configuration does something different. The FPM settings affect the web server. We might need to edit this file if we're ever seeing a pm.maxchildren error, which is where the server is unable to spawn additional PHP processes. The CLI configuration will change how our scheduled jobs, daemons, and queues work. It's the command line version of PHP that will be affected. And lastly, we're able to modify the PHP pools. By default, there is a pool that runs sites as the Forge user. Pools will also be created for isolated sites, which prevent other users from reading or modifying another site's files. Isolated sites are a powerful way of preventing third-party applications such as WordPress or WordPress plugins from running malicious code on our servers. If we open up one of these configuration files, we can see that Forge is showing the contents in a modal, and we're able to modify these files as needed. We're also able to install additional versions of PHP. Let's install PHP 7.4. Now this will take a few moments, and as this installs, you should know that older servers, or specifically those that are running end-of-line versions of Ubuntu, so currently that's 16.04 or below, will not be able to install additional versions of PHP. For those, you should provision a new server and move your sites to it. With PHP 7.4 installed, we can now see that we have the same settings as 8.1 had. And if we go to create a site, we can now pick which version of PHP we want to use. There we go. Now that 7.4 is installed on the server, we're able to change the CLI default and the site's default. However, we're going to leave these as they are for now. And finally, Forge will show us the binary name of each version of PHP on the server. We can also see the log files that exist on our server. And here we can see PHP 8.1 and 7.4. If we click into any of these, Forge will load the log file for us and we're able to see the full output. One of the best and probably most understated feature of Forge is that it essentially removes the need for you to SSH into your server to do anything. If you need to create a site, a scheduled job, a daemon, you can do it all within the Forge dashboard. However, what happens if we need to install additional software onto our server? Perhaps we want to install Elasticsearch or Socrates or MongoDB. In a previous video, we've looked at how you can use the site's commands panel and why you should use that for running one-off commands. But in this case, even that wouldn't be enough to install our software. That's because commands run as the site's user, which is typically Forge, meaning we wouldn't have the sudo permissions needed to install software or create system services. Instead, we need to use recipes. If we think of deploy scripts and the commands panel as scripts to run on our site, recipes are scripts to run on the server. This means that we can run code as the root user, which would give us the necessary permission to install additional software or to make those system configuration file changes. Let's start by creating a really basic recipe to see how this works. So we'll come down and create a new recipe with the name Who Am I? We can then select the user, root or Forge, and Forge will always suggest any of the isolated usernames that we have on any of our servers. For now, we'll keep it as root. And the script is just bash, so we're going to call it who am I, who are you? So here bash is going to evaluate this and give us the value that this comes back with, which will be the user who is logged in, which should be the root user. We'll come down and create this recipe. And then with that created, we will run it. And we don't need to email ourselves this one, but we do need to run it on this server. And now if we have multiple servers, we could run this recipe on all of those servers or just a handful of them. We'll run that, and then we need to come back to the dashboard, and we can see that we have our recent events, running recipe, who am I? We'll see the output of this. I am root, who are you? Cool. So let's just go back to our recipes panel and change this recipe to run as the Forge user. Save, run, and go back to the dashboard. Running recipe the second time. And here we go. We have I am Forge, who are you? So now that we can run code as the root user, we're able to install additional software. So in this case, we're going to install Sockety, which is a WebSocket service that is compatible with Laravel Echo. So we'll do npm install and then globally the Sockety package from the Sockety namespace. And create that. Now we will come and run this. We don't need to email ourselves. And now we can go back to the dashboard. So of course, depending on what it is that the recipe's doing, depends on how long these things will take. But if we give it a minute or two, Sockety should be installed and we should be able to view the output. And there we have it. Sockety has been installed on our server. And then finally, while we're on this page, you may have noticed the Forge recipe section. In this case, we have an update CA certificates recipe, and we can click into the details and see more information about what this recipe does. So this is a really powerful way for the Laravel team to create shared recipes that can fix common issues that we can run by ourselves. So far, we've been working on our own server. However, sometimes we're going to need to share our servers with colleagues, contractors, or teammates. Forge allows us to share both servers and the ability for members to create servers on our behalf through a feature it calls Circles. Circles are only available if you're subscribed to the business plan, but you do not need to be subscribed to Forge to join a circle. Circles have several benefits over account sharing. You're able to revoke a member server access at any time, just remove them from the circle. You don't need to share passwords and potentially risk being locked out of your own account. Forge keeps an audit log of who did what and when on each server, so using circles, you'll be able to see exactly what changes have been made and who made them. And circle members are not able to delete servers, only the account owner has that privilege. To create a new circle, we need to do a couple of things. We need to firstly give it a name, so we'll call this one Employees, and hit Create. Once the circle has been created, we can edit it. From here, we're able to rename the circle, and we can select which servers we want to be a part of it. So we will enable the Deep Sound server, and also share our Hetzner Cloud credentials. Once we've decided which servers and credentials are a part of our circle, we can now invite people to it. Now, when we invite somebody to a circle, they do not yet need to have a Forge account. They will receive an email from Laravel Forge instructing them to either create an account if they don't have one, and then to accept the invitation. I'm going to invite my good friend Taylor Otwell and hit invite. And here is the circle invitation email. James Brooks has invited you to join their employees circle. If you do not have an account, you can create one by clicking the button below, after which click join circle. Okay. So we will now create a new account, which I will do in an incognito window. And we will call it Taylor Otwell. Now keep in mind when creating the new account that the email address must match the one that has been invited. So taylor@stressedout.io. And finally the password, we need to make sure it's a secure one. Okay, and I agree to the terms of service and the privacy policy. I'll now click register. And since I've just joined Forge, it's showing me the onboarding screen where I can connect my source control and server provider details. but if I'm just joining a circle, I can skip this step. Now initially we're not going to see any active servers because we've not yet accepted our circle invitation. Let's go ahead and copy the link address and paste that in here. And just like that, we are now part of the employees circle. We can see the owner of the account is myself, James Brooks, and I'm not able to create circles as Taylor Otwell because he has not subscribed to a plan. Now that Taylor's part of the circle, he could go to the servers page and see the server there, and also see that it is a part of the employees circle. One of the cool things about circles is that we can use them to filter down our servers. Now in this case, there's not much to see. We have one server, but we're currently looking at all servers. We could look at servers owned by us, which are none, or we could look at the employees circle, which would just filter down servers that are part of that circle. Clicking into the server, we can see that we can manage everything. The only thing that we can't do here as a circle member is delete the server. That privilege is reserved only for the server owner. If we switch over to the server events page, we can see that there are already existing server events, all of which have been initiated by myself. This is because I'm the only person that's had access to this server so far. Now occasionally you might see another user that's initiated event, Laravel Forge. These typically happen when either a support agent has connected to your server or we've deployed code through a push to deploy system. So what I'm going to do here is add a new key as Taylor Otwell. I'm going to call it Taylor and add it to the Forge user, paste it in. And we can see that Taylor's key is now being installed. And because we are part of a circle and acting as Taylor here, if we go back to the events panel, we can see that Taylor Otwell has installed a new key. And this audit trail is very powerful when we're sharing servers with multiple people because we're now able to see who has done what and at what time. When we created the circle, we also shared our Hetzner Cloud credential. This means that we're able to create servers on behalf of the circle owner. To do that, we can click on the Create Server button, and we'll see initially that we're not subscribed to any billing plan to create servers. However, we'll also see that we've got this Create Circle Server button that we can click, and we can now select which circle we want to create the server on, which will be the employees one, and which credential we want to use. So we'll use the personal Hetzner Cloud, and then we can create a server as usual. If we switch back to my James Brooks Forge user, we can then go and edit the circle members and now see that Taylor Otwell is a circle member, and Forge is also showing us that two-factor authentication is not enabled by Taylor. This is a really good way of making sure that your servers are as secured as possible. You can now go and tell your circle members, please go and enable two-factor to secure your account. Have you ever lost the contents of a database before? Well, I can tell you from my own experience accidentally dropping a table or two, it sucks a lot. Fortunately, I was able to restore everything from a backup that we had taken previously. Forge provides automated database backups as part of its business plan, and when configured, Forge can automatically perform these backups on a schedule of our choice. The backup archives can be configured to upload to any S3 compatible storage provider, so there's no excuse for data loss when backups are made this easy. To get started, we need to head over to the Backups panel on our server. This panel will be available for any app or database servers, since we need a database on the server to actually take a backup of. Okay, let's scroll down and start filling in this form. So the first thing that we can do is provide an optional name for our backup. This is particularly useful if we're going to configure multiple backups on this server, and it's just a good way of quickly identifying a backup and maybe a backup failure email. For this, I'm going to call it ZonderDB. The next thing we can do is select the schedule that we're going to back up, and this is just a frequency that determines how often these backups are going to be taken. Forge already provides us with some common frequencies, hourly, daily, and weekly. And as we select daily or weekly, then we'll be shown the day of the week and the time that we want to back up. For daily, we're just going to see the time. Of course, if we want to back up on our own schedule, then we can select the custom option, and Forge will ask us to provide a cron expression. This is because Forge is actually just configuring our servers to run our backups using the server's own cron service. Of course, this does mean that our backups will run on our server's time zone. For this backup, I just want it hourly, please. Once we've decided on our backup frequency, we can choose where we want to store our backups. Forge's backup system is compatible with any Amazon S3 compatible storage provider, though occasionally a provider may not be 100% compatible and you might need to make some manual adjustments. However, if we're using Amazon S3, DigitalOcean Spaces, or Scaleway, then Forge is already 100% compatible. And again, we can always select the custom option if we want to use another provider. But no matter which provider we select, we'll always need to let Forge know where we're storing the backups. We'll always need to provide Forge with some information telling it exactly where it's storing those backups. In this case, I'm going to use DigitalOcean Spaces. And I'm going to select Amsterdam 3. And my bucket is called Forge Backups Test. I already have my access and secret keys generated, so I'm going to provide those now. By default, Forge is going to store backups in the root of the bucket. But if we don't want to do that, then we can also provide a storage directory to store them in. So I'm going to call it Zonda Database Backups. Next, we can select how many backups that we want to retain. On an hourly backup schedule, we might want to configure 24 hours, so we can go back to any hour of the day. And then after those 24 have been created, then Forge will start to prune them off the end, with the oldest backups being deleted first. We can also provide Forge with an email address that will be notified if any of our backups fail. And then finally, we can select which database or databases we want to back up. We can select all databases, or one database, or two, whatever it might be. For this, I'm just backing up the Zonda database. With all this information provided, we can create our backup. And when we click this create button, then Forge is actually going to validate all of the credentials. And if they're incorrect, we can fix them up and just try again. So when we're creating a new backup configuration, Forge is creating a bash script on our server. And this is what's executed by the cron service. This script tells the server to dump the database and stream the contents to our S3 storage provider. And once it completes, whether it's successful or not, then the script is going to ping back to Forge with that status and send us an email notification if we've configured it. At the time of recording, Forge doesn't actually support Slack failure notifications, but a way of working around that is to use Slack's email to channel hook and supply this as the email to receive notifications. That way we can start to receive notifications in our company's Slack channels. Now that Forge has finished creating the backup configuration, we'll manually run our first backup. Because this database only contains our small Zonda database, it'll only take a few seconds to complete. And now we can see that the last backup was successful and taken 4 seconds ago. If we scroll down a bit further, we can see our recent backups with the name and ID of the backup configuration, the date and time that the backup was taken, and how long that took. One of the cool things of Forge's backup feature is that we can also download the database archive directly from our browser. If we just click the name of the database, Forge is then going to download that file for us and we can see it's created there. Then we can see the databases in this backup and also the status of it. If our backup has failed, then we can also choose to see the backup output. This will allow us to see what's gone wrong with the backup and we can contact Forge support or make any adjustments to our backup configuration. Okay, so let's verify that this backup has been created. I'll switch to DigitalOcean Spaces dashboard, give this a refresh. And we can see we have the directory that we told Forge to use. We'll click into that and we'll see the timestamp of when the backup was taken. And if we go into that, we can see our database file. Let's switch over to Table Plus and we can see that we're on our Zonda database. This database contains a few tables, all of which are pretty much empty. So what we can do is select our tables and delete them. And then we can go back to Forge and click Restore. Now, of course, because we're able to download those individual database archives, we could always choose to restore manually and with an application like Table Plus, choose which tables that we want to restore. In this case, we've deleted all of the tables, so we need to restore that whole Zonda database. Forge is now going to download this archive to our server, extract it, and then import it to our database. Let's switch back to Table Plus, give this a refresh, and we can see that Forge has now restored all of our tables and our data that was in those. And then finally, if our backup configuration changes, we can always go through and edit this. Here we'll see all of that information again, and we can choose to modify it and then save it. If you're providing a service that customers depend on, it's crucial that we make sure our server is monitored and we get notified before it goes down and completely ruins our evening. Forge provides active server monitoring as part of its business plan. Forge's server monitoring works by installing an agent onto your server. That agent will then periodically run every minute and check for the different monitors that we've configured. That means that if we're only interested in disk space, then we're not going to also be checking the CPU load average or the used memory. When the threshold has been met for at least the amount of time that we've configured, then Forge is going to notify us. Once that threshold has been met, your server is going to continue monitoring the statistics and then notify us when everything resumes back to normal. With Forge's server monitoring, we can configure one of 3 different monitor types. The CPU load average is the average amount of load the server has experienced over the last few minutes, and a good rule of thumb is to ensure no more than 70% of our CPU is in use on average. The use disk space option allows us to track how much of the disk is currently in use. And if our server nears to 100% of the used space, then there is a high chance our web server will crash and everything will become unresponsive. We can avoid excessive usage by storing things like user-uploaded files off our servers and perhaps using something like Amazon's S3 service. The used memory is the percentage of memory in use. When configuring a monitor for used memory, we need to be aware that if our server is also running a database server, such as MySQL, then we should immediately expect a higher memory usage, and we will need to account for that by setting a higher threshold for the monitor. For this example, let's go with used memory. We can now check whether that value is greater than or equal to a threshold. In this monitor, we want to make sure that we're not hitting above 90% of our used memory. For this monitor, we want to make sure that we don't hit above 90% of our server's memory. And then we can also select how long that this should be happening for before we get a notification. If we experience 15 minutes of a high memory usage, maybe that would be okay for a lower threshold, but anything around 90%, we want to be aware of it very quickly. Let's say a 5-minute interval. And then finally, we need to provide Forge with an email address to notify. In this case, I'm going to go with james@laravel.com. And we can create. Now that 5 minutes have passed, we can see that the monitor status is now okay. If we simulate a high memory usage on this server, we will see that it changes to an alert state. And once we let everything settle down, it will return back to OK. Each time this status changes, then Forge is going to send us an email notification to let us know where we're currently at. Laravel Octane is a package that supercharges our application's performance by serving it using a different kind of server. Octane is compatible with OpenSWOOL, Swool, and Roadrunner. It works by booting our application once, keeping the entire thing in memory, and then feeding it requests at supersonic speeds. And of course, Forge supports Laravel Octane. Octane can only be enabled when creating a new site. So we're going to go ahead and give it the same old domain, zonda.quest, and we're going to select a different type of project. This time we're going to select Laravel Octane. Unlike other project types, Octane will not use PHP FPM. Instead, Octane starts its own server, Roadrunner or Swool, and uses Nginx as a reverse proxy to forward requests to it. When we select Octane, we'll see that we need to also provide a port. It's wise to use a high number such as 8000 as to prevent clashes with other software that may be running on our servers. At this point, everything else can stay the same and we can create our site. With our site created, we need to install our repository. Forge is slightly different for Octane-powered projects. If we scroll through, we can see that the deploy script is slightly modified. Instead of reloading PHP FPM, we're going to reload the Octane service. A little further down, we can see that we have a Laravel Octane panel containing some further instructions. This is because we need to run a couple more things to get Octane running. The first thing we need to do is create an Octane server environment variable and tell Octane which server it is that we want to use. Let's copy this and go to the environment panel, and we will use Roadrunner. And now head back to the Laravel Octane panel, and the next thing we need to do is create a daemon. We'll copy this command and go to the daemon panel and create the new command. We'll paste that in and tell it that we want to run this command in our sites directory, and then everything else can remain as it is by default. Let's create the daemon. And if we now switch to our site and reload this, then we will see our application is being served by Octane. We can confirm that this is working by going back to our site, and we'll see this little Octane icon. We can click into our site and click in the Deploy Now button. We can then check that Octane has reloaded by going to View Latest Deployment Log. And if we scroll down, we will see the Octane server is currently running. That's the status part of our deploy script. And then we're reloading the workers. Previously, we sped through the provisioning process and skipped over some of the options that are available to us when we're creating a new server. Let's take a look at this in more detail, and we'll start with the server providers and how we can configure them. Now, Forge has first-party support for several providers, including DigitalOcean, Linode, AWS, Vultr, and Hetzner Cloud. A first-party integration means that Forge will actually be able to create the server at the provider of our choice, and in our own accounts. Further, if we decide we've had enough of that server and it's no longer needed, we may delete it from the Forge dashboard, and it will also be removed from the provider's dashboard too, and thus we'll stop paying for it. I've previously mentioned that we may also bring our own servers to Forge. All servers that are provisioned by Forge use Ubuntu, currently supporting 20.04 and 22.04. This means that as long as our custom server meets the requirements listed on the Forge documentation, it will be compatible and provisionable with Forge. So since we already have the Create Server modal open, you can see that I already have a Deep Sound server in the background here, and that is with Hetzner. That's a provider that I have already configured. Now, of course, I can always go through and select another provider, let's say DigitalOcean, and because I've not yet configured it, Forge is going to take us to the account settings page and the server providers panel. And from here, I can add new providers. So I can select DigitalOcean, Linode, or another one, and I can provide a profile name, which is just the identifiable name that we're going to give this credential. And this name is particularly useful because we can have multiple credentials for each provider. So here I might call it personal, and then I can provide an API key from DigitalOcean itself. And we can generate those through the provider's dashboard. Once we've configured our server providers, we will see them listed below on the active providers list. Here I can see the ID of the provider, which is useful if we're using an API request, the name that we gave to this credential, the provider of choice, and whether it's already in use. And then we can edit this credential and change the name or update the API key if required. Okay, so let's head back to the dashboard here and open up the Create Server modal once more. Since I've already configured Hetzner, I'm going to select this as the option. Okay, let's work through this form top to bottom. So the first thing we'll see is that we have the ability to choose the server's operating system. By default, it's selected as 20.04, but we can also select 22.04. The difference between these two currently is that Forge is not able to install any other version of PHP than 8.1 when using Ubuntu 22.04. So if we require an older version of PHP, we must use Ubuntu 20, and then we'll be able to select multiple versions of PHP. Now, Forge can provision different types of servers for us, each with its own purpose and speciality. When we open up the Type menu, Forge will helpfully show us an overview of which services are installed for each server type. App servers are general purpose. They include everything we need to run our app in a self-contained server, including PHP, Nginx, database, Redis, and Memcached. Web servers are light-purpose app servers, and they don't include a database or cache services, meaning we're only running PHP and Nginx. Worker servers are lighter still and are designed for running queue workers. Database server only runs MySQL, MariaDB, or Postgres, depending on which we choose. Note that these are not managed databases like what DigitalOcean or AWS offers. They'll only ever run the database directly on the server owned by yourself. Cache servers include Redis and Memcached. MeiliSearch servers only run MeiliSearch, which is an alternative to Algolia or Elasticsearch, and they allow you to provide local search results from your data. And finally, the load balance server runs Nginx and is designed to balance traffic between two or more web or app servers. They work by utilizing the private network feature of Forge and will connect other web or app servers together. For this, we'll create an app server. Now, Forge will automatically generate a name for our server, but if we want to use our own naming conventions, we may change this. For instance, Laracasts Curved Thunder, or we'll just leave it as default. Now, when creating a server with a first-party provider, we're able to select both the region to create the server in and the size of the server. Each provider supports different regions and sizes, and remember that we will be billed for the server we create separately by the provider we've chosen. So here I can select Falkenstein, Nuremberg, Helsinki, Ashburn, and different sizes here. These options are not available when using a custom VPS because the hardware is already decided on. Next, we may select which VPC to connect our server to. A VPC, or a virtual private cloud, is just a secure and isolated network that we can place our servers into. And this will allow us to connect our servers together and keep all internal traffic within the network, meaning our data is safe and secure. For example, if we provision a web database and cache server, we'd want to be able to connect them together so that our web server can access the data and cache servers. When we're creating a server that installs PHP, we may also select which version to install from, and we can select anything from 5.6 all the way up to 8.1. If we're creating a server that installs a database, such as a database server or an app server, we may select which database and version to install. Here we can install MySQL 8, MariaDB 10.6, and PostgreSQL 12, 13, and 14. By default, Forge will also create a database called Forge on the server, but we can change that name to anything we like, such as app or demo or prod. We'll stay with Forge for now. Recipes are scripts that we can instruct Forge to execute our server once it is provisioned. This is particularly useful if we want to install additional software or make customizations to our servers that are beyond the scope of what Forge is doing for us. And finally, there are some additional options we can select. We may choose to add our service key to our connected source control providers, and typically we'll only want to do this on app or web servers so that they are able to clean our projects. And then occasionally a server provider such as DigitalOcean or Hetzner will allow you to take daily backups of your servers. These backups can be enabled by checking the relevant backup box. Keep in mind that these are typically billed at a separate cost by the provider. Okay, so that's listed all of the options available. Let's create our server and check out the provisioning screen. When we first land on the server's provisioning page, Forge will show us the sudo and database password, or MeiliSearch if that is available also. These will also be emailed to us when the server has finished provisioning. And if we close this modal down, Forge shows us the progress of the provisioning process and explains what each step is for, and will update the active state as it progresses. Once this is finished, Forge will redirect us to the server's dashboard and we can go ahead and start to create our sites. So far, we've been dealing with one server, the DeepSound server here. But let's say we spin up an additional server, DeepSound 2, and now we want to distribute the traffic between these two servers. We can do this by using our load balancer. We can provision a new server by going to Create Server, selecting the same provider that our two servers are already on, and then we can select a load balancer. Now this must also be in the same region and also on the same private network. Now in the meantime, while this provisions, there's another thing that we need to do. Our DeepSound server contains a site called zonder.quest. For a load balancer to be able to correctly distribute the traffic between two or more servers, each server has to have the same site. So let's go to DeepSound 2 and create zonder.quest. Okay, we will install the same project. Now both of our servers have a site called zonder.quest. With our load balancer now provisioned, we just need to add our site. So we will add zonder.quest again, and we'll add that in. Once the server has finished provisioning, Forge is going to show us the Balance Servers panel. There's a few things to go over here, so we'll work through this one by one. The first is the balancing method. Forge allows us to select one of three different balancing methods which determine how traffic is split between our load balance servers. Round robin will just equally distribute the traffic. Least connections will send traffic to the server with the least connections. And IP hash is like a sticky session, so if you land on server 1, then you'll get server 1 over and over again for a period of time. We'll use round robin in this case and add our first server. So Forge will list all of the servers available on that provider in that region and that have a private IP address. We'll add DeepSound. We can now select which port we want to send our traffic to on this server. For most PHP and Laravel applications, port 80 is absolutely fine. We don't need to change this. However, if we're using an application like Nginx, we might need to change that. We can also choose to weight a server so that it will receive more requests than another. We can choose to make a server a backup, which will just mean that if all other servers on this load balancer are down, then this server will receive all of the traffic. And then finally, we can choose to pause the server, which removes it from the pool of balanced servers. This is just a convenient way of removing a server without then needing to re-add it in again. Okay, so let's add our second server, and we can leave this all the same and click Update. Now, if we head over to our site currently, I've added a server route which just returns the server's hostname. If we refresh this, we'll get DeepSound over and over again. That's because we haven't yet updated our domain's DNS records to use these load balancer's IP address instead. So let's do that. We'll grab the IP address from Forge, and then we can go over to our DNS provider. In this case, I'm using Cloudflare, and I will update our IP addresses. I'll do both just for good measure. And if we switch back over to our site again and give this a refresh, we can see that our site is now being balanced because it's equally distributing the traffic between our two servers. Okay, finally, we can add an SSL certificate. So we will go to Let's Encrypt and add that on. So when using SSL on the load balancer, it's only the load balancer itself that needs to request the certificate. So the certificate is now active, and we can head over to our site. Now with the certificate activated, we can refresh and we'll see that we have our certificate already added. And again, our site is still responding in the same way. Traffic is being distributed between our two servers. Aside from just web and database servers, Forge is also able to provision servers with MeiliSearch. If you're unfamiliar, the MeiliSearch website describes it as an open source, lightning fast, and hyper-relevant search engine that fits effortlessly into your app's websites and workflow. And best of all, MeiliSearch is also 100% compatible with Laravel Scout, and so it can easily be added into our Laravel applications. To get started with MeiliSearch, we need to provision a new server. We'll go up to Create Server, and we'll select our provider, and we can just select a type. We'll use MeiliSearch, and I will make sure that I add this to our network. And we can click Create Server. Now this time, when Forge shows us the server credentials modal, it will give us our sudo password, but it will also contain the MeiliSearch password. We'll need this when our server has finished provisioning to get access to our MeiliSearch API keys. Once our server has finished provisioning, Forge will take us to the server's dashboard, and we can see that we have one active site here, which is the default MeiliSearch server. If we go to our server's IP address, we can see that we have a JSON response saying status MeiliSearch is running. Now we can also see that Forge is showing us a MeiliSearch panel. This panel is specific to MeiliSearch servers, and we can provide it with the password that we were shown when we started to provision the server, but it will also be an email to us. We can then reveal the API keys. So we need to use the admin API key. This is what is used on the back end and should not be used on the front end. So we will copy that, and we also need to make a note of the server's private IP address. We'll then head over to our site and go to the environment. And now we need to make a couple of changes. We're going to add the Scout driver, and we'll install Scout in a second, but we will say MeiliSearch. And then we need to add MeiliSearch host, which is HTTP 10.0.0.3, and then MeiliSearch runs on port 7700. And then finally, we need to add the MeiliSearch key, and this is what tells Laravel Scout that it can authenticate and add our records. Let's click Save. So the next thing that we need to do is install Laravel Scout. We can do that with the composer require Laravel Scout. Once that's installed, we can do artisan vendor publish, and we will need to install the Scout service provider. Once Laravel Scout is installed into our project, we can then make a few changes. The first thing to check is the Scout configuration file. Now we've already configured Scout driver, but by default it will use Algolia. Algolia is an alternative to Elasticsearch, but it is a paid service. The next thing we need to do is add the Scout searchable trait to our model. This is what tells our application to add our records, our database records, to MeiliSearch whenever they are added or updated. And then finally, I've just added a search route here that will create a new person based on the first name, last name, and age. We'll use this to demonstrate how MeiliSearch works. And before we can deploy this, we also need to add the MeiliSearch library to our application. The Laravel documentation tells us how to install this, and also for other providers too. With Scout installed and our application deployed to our server, we can now demonstrate how this works. So we'll go over to our search route, and first name is James, last name is Brooks, and my age is 30. And there we go, we shouldn't expect anything because we didn't have a response. We'll now do the same for my wife Katie, and it's added that in as well. We can verify that the index has been created and the records added to it by using an application such as Insomnia or Postman. Here I'm using Insomnia, and I have my server's IP address and indexes. I've configured a bearer token to use the API key, and if we request this, we can see we have a people index. We can then see all documents inside of this index by going to the index ID here, which is people, and the documents. And we can see now that we've got James, age 30, and Katie. Our application can now use Scout to search our MeiliSearch data. Servers provisioned by Laravel Forge are secured by default. For example, you can only connect to your server via SSH if the key is already added to the server, and you can only connect to a database via an application. For example, you can only connect to your server via SSH if the key is already added to the server, and to connect to a database using an application such as Table Plus, you can only do so over an SSH connection. However, sometimes you do need to make changes to the network access of your server. such as allowing MySQL to be connected to without SSH, and we can make these changes through the server's network panel. As we work our way through this panel, we can see that we have a server network card. This allows us to connect individual servers to each other and bypass the firewall rules. For example, if we have a database server and a web server, we can allow the web server to connect to our database server. It's as simple as checking the box and clicking update. Now the Deep Sound server can connect to the Hidden King MeiliSearch server that I have configured. Now as we scroll down this panel, we can see that we have the new firewall rule 4, and we can explain this further and what this does by scrolling down to these active rules below. When Forge provisions a server, it will add 3 default firewall rules. This is to allow port 22, which is the SSH service, to any IP address, port 80, which is the HTTP service to any IP address, and likewise for HTTPS. So SSH, HTTP and HTTPS can be accessed by anybody. Now we can add a new rule to demonstrate how this works. Maybe we'll call it block James, and we'll remove port 80. So currently I can access the server and see the Laravel default page on the IP address, and I can refresh to confirm that's still true. Now we can remove port 80 by itself, or we can add a colon and supply another port. And now this will do a range, so everything between 80 and 443 will be removed. And then finally I can supply an IP address. If I don't supply an IP address, then everybody will be blocked to this port, and we will deny it. So now I can no longer access port 80 or anything up to 443. We will add that rule and see that it is being created here. And once that rule is added, I can switch back to our site and refresh. And now it's going to spin indefinitely until a timeout happens and I'm blocked. And there we go, we've got a HTTP error 504. We can now remove this rule and switch back to our site and give it a refresh, and access has been restored. Now sometimes we might need to be explicit about the IP addresses that can connect to SSH. Before we make any changes to the SSH rule, we need to always allow the Laravel Forge IP addresses. Laravel Forge's IP addresses are listed in the documentation. You should make sure that these IP addresses are always enabled before making changes to the SSH rule. If you remove this firewall rule before allowing Forge's IP addresses, then Forge will no longer be able to connect to your server, and you will need to manually restore access. More often than not, we're going to need to install dependencies using Composer for our general PHP and Laravel applications. Most of the time, these dependencies will be free to use and will not require any additional setup. However, sometimes we're going to want to install premium packages like the ones offered by Laravel, such as Nova and Spark. These packages will require additional authentication configuration so that they can be installed. Forge offers 2 ways to manage these credentials. The first is on a server level, which we can access through the Server's Packages panel. This panel controls the global auth.json composer configuration file. This means that any sites installed onto this server will be able to access the shared credentials. Forge is particularly clever in the way that it manages composer authentication. The auth.json configuration file is loaded on demand from the server, and so no credentials are actually stored by Forge. To add our first credential, we need to click Add Credential. Now let's imagine we're installing Laravel Nova. We will need to supply the repository URL, which is nova.laravel.com, and the username, which will be our account email for our Laravel Nova license, and the password. In the case of Nova, we will have a generated API key that we can supply. We can also choose to add another credential and store as many as we need to, but for now, configuring Nova is fine. We'll hit save, and Forge has now configured our auth.json file. But let's say that we have a site which runs a different version of PHP and therefore requires a different credential for our package. To do that, we can go over to our Sites panel, select the site that we want to work with, and go into the Sites Packages panel. Now this panel works slightly differently in that it will pull the auth.json file directly from our sites directory. This means that we can control just this site's composer credentials. It works in exactly the same way in that we can add a credential, and we will do nova.laravel.com. But let's say this time we're using my Laravel email address and a different password. We can click save, and there we go. Forge has updated our site's auth.json composer file. Now this file should not be checked into source control because Forge is actually writing a file within our site. And when we try to deploy, that file might be overwritten and there will be merge conflicts or potential that that file cannot be updated. When we first create our Laravel Forge account, we need to add our SSH keys to our account. We can do that by going to the dropdown, Account, SSH keys, and filling in this form. Now all keys added here will be automatically added to any server that we create from here on. So I'm going to create one called James MacBook and paste in the contents of my public key and click add. With this key added, I can add it to any of my existing servers. So I can click add to servers and see that I have a server called Deep Sound. Now currently if I try to SSH into the server, it's not going to let me do it. Permission denied because my key isn't added to the server. I can select which server I want to add this key to and click add key. Now when I switch back and try and connect again, Forge will have added the key and I'm now able to connect. Let's exit out of here, but let's say that we want to give somebody else access to our server. We don't want to add their SSH key to our account because that means that any servers that we create, they'll have access to going forward. Instead, we can go to the servers panel and go to SSH keys, and we can add a key here. So again, we need to give the key a name. We then need to select which user we want to add that key to, and we can select Forge or any of the isolated sites, and then we can paste the key in. We'll add that key. Once this key is installed, this user will be able to access the server over SSH, but also SFTP. This means that we can give clients or customers access to our server to upload files without needing to give them full access to our server. When adding a new site to your server, Forge is also going to configure Nginx to explain what domain it should be listening for and how to respond to those requests. The default Nginx configuration file used by Forge is quite a standard and albeit basic configuration file. Now we already know that Forge is capable of running more than just PHP applications, and so if you were configuring multiple non-PHP sites on your server, it could be quite a tedious task to manually edit each configuration file as you go. Forge makes this much easier to manage through a feature it calls Nginx Templates. We can find this panel under the server's dashboard. When creating an Nginx template, Forge needs two things: the name so that we can identify the template later, and also the content of the configuration file. Let's say that we're going to create an endpoint served by Nginx just to check the health of our site. We'll call it health endpoint. Now Forge is already showing us the default Nginx template that it uses, and in some places it's using different variables. Laravel Forge's documentation contains all of the variables that we can use and also explains what they do. Okay, so we're going to scroll down a bit and add a new location. We'll call it health, and it's going to need to add a header of content type, and that will be text plain. And then it's going to return a 200 and just say healthy. Let's create this Nginx template. And when we go to create a new site, which we will call default, we can select the Nginx template used to create the site with. We can choose to use Forge default or the health endpoint that we've just created. And now when we add this site and we access the health endpoint, we can see that it's returning healthy.